Okay, this is a walkthrough for the practice test on triangle properties and logic. So the first part here, we have this proof. Always with the proof, the first thing that we're told is the given information. We were told in this problem that 5 times, make that bigger, 5 times the quantity x minus 2 is equal to 10. That's the first thing we put in our proof, which is why that first line is always given. We have to restate what we were told at the beginning of the proof. And then we simply distribute 5 times x and 5 times 2 to get 5x minus 10 equals 10. So that was distribution property. Then we would, to finish solving this, we would add 10 to both sides to get 5x equals 20. That's the addition property. And finally, divide both sides by 5 to get x equals 4. That is the division property. For problems 5, 6, and 7, it might be helpful to have scratch paper. That's the way I always do it, where I can highlight the parts that I know. For example, the first part in number 5, it says VT is 16. So I put that in the picture with the little green thing. That length is 16, and it wants to know what the length of VP, the red part, is, and then the whole thing. Well, in the directions, it says that these are all medians, and that point V is the centroid. That means each of the medians is cut into 2 parts. A short part, in this case the green, and the long part, in this case the red. And the rule is the long part is always twice the short part. So for this problem, VP is going to be 32. And then the follow-up question, PT, that's the whole length. Well, we just add those two together to get 48 for the full length. For the second problem, or number 6 in this case, it says QV is 20. That, QV, that's the long part of this median. And then it asks what VU is, that's the shorter part of the median. So if the long part is 20, the short part's going to be half of that, and that's going to make that 10. So the green part is 20, that means the red part's 10, and then the follow-up question, what's the length of the whole thing? We just add them together to get 30. So if you missed that, we're told the green part is 20 here. The red part here has to be half of that, so it's 10. And then the total distance, Q all the way to U, we just add those together. Now the third one of these problems says S to V is 12. So that's the short part. So we're going to double that to get the green one here. So VR would have to be double that, or 24. And the whole. For the next section, and expect to see some of this on your test as well, we're looking to identify the special segments we see in the triangle. You have to look at what marks are there. In the first problem, we have marks showing that the two angle, this angle up here on A is broken up into 2 angles, and they're the same measure. The angle is cut in half. There's nothing about the sides or a right angle, but the angle is cut in half means it's an angle bisector. The second problem, we don't see any right angle symbols. In fact, nothing but angles. All we can see is that one of the sides is cut in half. We know the side's cut in half because of these little marks here and here. The side cut in half means this point here is the midpoint connected to the vertex. That is a median. How do you remember that? Well, that's something you have to remember. If you have to write that down, go right ahead. Write it down, draw yourself a picture. Problem number 10, here we have a right angle. We have no sides cut in half, no angles cut in half, just a right angle and a segment that joins one side to the opposite vertex. That's our definition for an altitude. In problem number 11, we have a right angle, that's the word perpendicular, and the sides cut in half, that's a bisector, so perpendicular bisector. Finally, number 12, I always think the mid-segment's the easiest one because we break our triangle up into 2 triangles that are the same shape, one little one up here and then a big one, and basically that little one's going through the middle of the triangle, so it always comes up with mid-segment. Okay, for the other problems on the page, the top of page 2 here, the top 2 problems have to do with a mid-segment. Hopefully you can identify that this is a mid-segment based on the problems we just did. And the rule for the mid-segment is you double the mid-segment to get the length of the parallel side. And I know it's easy to think of taking half of 36 and setting that equal to 6x, but that's very hard in the second problem. So it's easier to take the mid-segment, double it, so it becomes 12x, and set that equal to the side it's parallel to, so 12x equals 36. And when you solve for x, you get 3. Same thing in number 14. Take the 26 and double that, that's 52, and set that number equal to the parallel side. So 52 equals 2x plus 8. When you solve for x, you should get 22. It's a lot harder to take the long side and divide it by 2. It's a lot easier to double a side than to take half of it. In problem number 15, we got 2 triangles. Their side lengths are 32 and 25. or we know the two of those side lengths. We want to know the third side length. Well, it can't be 1,000,000. The two sides would be too short. The limit is what we get when we add and subtract those numbers. If you add them up, you get 57. If you subtract them, you get 7. The third side has to be between those two numbers, between 7 and 57. So those are our two answers. It's got to be less than 57, but more than 7. For problem number 16, trying to decide if we can draw a triangle. Well, the way we tell is we add the two short sides. They have to add up to more than the big side. So in the first problem here, the two short sides are 11 and 12. If you add 11 and 12, that's more than 15, so that one's okay. In the second one, though, if you do 3 plus 4, that's not more than 7. It's equal to 7, but that's not enough. It's got to be more than. So B is a no. In the letter C, make sure you're checking the order because the two small sides are the 12 and the 6. And when you do 12 plus 6, that's not more than 19, so no, you can't make a triangle. And finally, in letter D, if you do 15 plus 24, that's definitely more than 25, so that one is a yes. Bottom of page 2. All right, the first problem, number 17 here, says the triangle has these three angle measures. What we know about the three angles in a triangle is they add to 180. So we'd say this angle plus this angle plus this angle is 180, and that's what our first line of the equation is. Then you simply combine like terms. If you do that, you'll end up with 24x minus 12 is 180. If we add 12 to both sides and then divide by 24, we get x is equal to 8 for our answer. The follow-up question says, what's the measure of the largest angle? Well, we have to take the 8 and plug it back in for x in each of them. 10 times 8 minus 10 is 70. 8 times 8 minus 4 is 60. 6 times 8 plus 2 is 50. So what's the measure of the largest angle? It's the 70. That's the biggest angle in that picture. For problem 218, it says the triangle is equilateral. That means all the sides are the same. Here's one side is 5x, one side is 4x plus 2, and one side is 7x minus 4. But if it's equilateral, they're all the same. So basically, you can set any two of these equal to each other, and you'll get the same answer. You could say 5x equals 4x plus 2. You'll get x equals 2. Or 5x equals 7x minus 4, you get x equals 2. Or 4x plus 2 equals 7x minus 4, you get x equals 2. No matter which two you set equal to each other, you get the same length of the side. Then it says, again, to plug it back in and see what we get for the side lengths. Well, 5 times 2 is 10. 4 times 2 plus 2 is also 10. And 7 times 2 minus 4 is also 10. We get the same one for all three sides. That makes sense because it said the triangle was equilateral. They should all be the same. Okay, number 19 would be one of the harder problems here, but it actually isn't too tough. You don't know where to start, and that's the biggest problem, but none of the steps in here are that hard. What we do see is on the bottom, we have an equilateral triangle. All three sides are marked the same. And the one rule we have about equilateral triangles is that if the sides are the same, then the angle's the same. And if you did your homework, you know that all three of these angles measure 60 degrees. So all three of these angles in this triangle on the bottom measure 60 degrees. And because of vertical angles, if we know this one's 60, then this one's 60. So we have a 60 degree right here. Then, if we have 60 degrees and 70 degrees, we can find angle B. See, again, we got 60 for all the angles on the bottom. Then because of vertical angles, this one's 60. Then we can do 180 minus 70 and 60 to find angle B. And the angle B turns out to be 50. And we can look at this triangle up here on top, and we got to find these three measures. But again, we see vertical angles here. If this angle is 70, then angle C is also going to be 70. So we've got that one. Then angle B here is the same as it is over here. This angle B is 50. This is also B. They're supposed to be the same letter B, so that must be 50. And if we want to find angle A, we just subtract 50 and 70 from 180, and angle A will turn out to be 60 degrees. Okay, on the bottom of this page, problem number 20, we have an isosceles triangle. If these are the two congruent sides, they're basically pointing at our congruent angles. So if this angle is 80, so is x, so we get x is 80. And then to find y, we just subtract both those from 180, and we're left with 20 degrees. For number 21, again, the hardest part about this is figuring out which two angles are congruent. But the little tick marks are basically pointing at the angles. The y and the 62 are the same, so y is going to be 62. To find x, we subtract 180 minus both of these. 180 minus 62 again, we're left with 56. For number 22, it tells us the whole big angle is 80 degrees, and the red arrow through the middle is the bisector, cuts it in half, which means each of these little blue angles is 40. And LKM, that's one of those little blue angles. So we set this measure equal to the angle, 12x minus 4 is equal to 40. It does come out to a decimal in this case. You should get 3.66666 repeating, or 3.67. Okay, on the last page, the first problem asks us to name the sides of this triangle from shortest to longest. You have to remember that the shortest side is always across from the smallest angle. So in this case, our smallest angle is the 50. So the shortest side is the side that's across from it. It should be XY. So that's our first one. Then the medium side will be across from the medium angle. Here's our medium angle is 60. So the medium side all the way across from it should be XZ. And the largest side is across from the largest angle. Here's the biggest angle. So YZ is the biggest side. For the Monkey Island problem, okay, so this is probably the hardest problem on here because you're not given a picture, you got to come up with it yourself. Sorry for my terrible triangle drawing here. But we have a triangle. One side of it is 3 miles, one side is 2 miles. And getting that picture, once you have that picture, the rest is easy. But this is all we got. We got 3 objects, West Leiden, East Leiden, Monkey Island, and we're given these distances. So if you have that picture, all we're trying to do is figure out about this last distance. Well, this is the triangle inequality. The last measurement is 6. Could I have a triangle with side lengths 2, 3, and 6? No, because the two smaller sides, 2 plus 3, do not add up to more than 6. So the answer to number 24 is no. Expect a somewhat difficult problem involving the triangle inequality rule. Finally, for problem 25, we are trying to classify our triangles. Okay, so for these problems, the first triangle, all the sides are the same. That makes it an equilateral triangle, and all the angles in here have to be 60 degrees, which makes it acute. So it's an acute equilateral triangle. Problem B, we see a right angle here, makes it a right triangle. None of the sides are the same. We got no reason to believe that they would be the same. So if everything's different, that's scalene. C, just the opposite, we have the right angle, but now 2 of the sides are marked the same. So it's both right, but now 2 sides the same, so that makes it isosceles. Problem D, make sure you find that third angle before you make a decision. If you subtract 180 minus 34 and 55, you're left with 91 degrees. That makes this triangle obtuse. And since all the angles are different, all the sides will be different, so it is scalene.